Dielectrics. Dielectrics are the insulating materials which transmit electric effect without conducting. They are also a type of insulators that become polarized in the presence of an electric field. Polarized in the presence of an electric field, that is the center of positive charge, due to protons in the nucleus of each molecule of them, will be pulled in the direction of the applied electric field, and the center of negative charge, due to electron cloud due to electron cloud electron cloud due to electron cloud surrounding the nucleus in a direction opposite to the electric field. A few examples of dielectrics are: number one, few examples of dielectrics are dry gas, that is dielectric gas. Number two, mica ceramic glass. And plastic are the dielectric solid material. Number three, distilled water. Dielectric liquid. There are two types of dielectrics. Number one, non-polar dielectrics. Number two, polar dielectrics. If we compare non-polar dielectrics and polar dielectrics, so we can compare non-polar dielectrics and polar dielectrics. Comparison between non-polar dielectrics and polar dielectrics. So we can draw a diagram of non-polar dielectrics. In this case, so positive center of positive charge and negative charge coincide each other. That means center of positive charge coincides with the center of negative charge, and here center of positive charge will be separated from the center of negative charge for polar dielectrics. Here center of positive charge will be separated from center of negative charge. For non-polar dielectrics, we can write the center of positive charge due to positively charged protons in the nucleus, due to positively charged protons in the nucleus. positively charged protons in the nucleus protons in the nucleus of a nonpolar dielectric nonpolar dielectric coincides coincides of a nonpolar dielectric material coincides with the center of negative charge due to electron cloud surrounding the nucleus with the center of negative charge due to electron cloud surrounding the nucleus or revolving around the nucleus due to electron cloud orbiting the nucleus. The center of positive charge for polar dielectrics, we can write that the center of positive charge and negative charge, centers of positive charge and negative charge, center of positive charge and negative charge of a polar dielectric material of polar dielectric materials do not coincide with each other, do not coincide with each other do not coincide with each other. Number 2, on the left hand side, the molecules of nonpolar dielectric materials, the molecules of nonpolar dielectric materials or nonpolar dielectric have zero electric dipole moment, as electric dipole moment because dipole moment of one molecule will neutralize the dipole moment of other molecule. And also what we can say, that means the distance between positive charge and negative charge is zero. That's why dipole moment will be zero. Right hand side, number 2, each molecule of polar dielectric, each molecule of polar dielectric has certain electric dipole moment, has certain amount of electric dipole moment, certain amount of spontaneous electric dipole moment. Number 3, molecules The molecule of non-polar dielectric is symmetric. Non-polar dielectric is symmetric. Is symmetric. But on the right hand side, each molecule of polar dielectric, each molecule of polar dielectric has asymmetric configuration or asymmetric shape. Asymmetric shape. Number 4, examples of non-polar dielectrics. Examples of non-polar dielectric: nitrogen, oxygen, benzene, methane, etc. are the few examples of non-polar dielectrics. Nitrogen, oxygen, benzene, methane, etc. Methane, etc. are few examples of non-polar dielectric. Right hand side, nitrogen, oxygen, benzene, methane have the symmetric construction or configuration, and right hand side examples of polar dielectrics are water, alcohol, carbon dioxide, ammonia, hydrochloric acid, water, alcohol, carbon dioxide, ammonia, hydrochloric acid, etc. are few examples of polar dielectric. CO2, NH3, etc. HCl,